επόμενος ομιλητής επίσης από τις Ηνωμένες Πολιτείες μέσω Skype είναι ο Κοσμάς Καραδημητρίου. Είναι Director of Analytics στην KAYAK. Έχει συνειδρήσει και έχει συμμετάσχει σε 3 εταιρείες και έχει 9 πατέντες. Σπούδασε φυσική ενώ έχει διδακτορικό σε Computer Science. Έχει δουλέψει στην NASA. Με διορθώνεις ότι κάνω λάθος. Έχει δουλέψει στην NASA. Έχει δουλέψει και το US Department of Defense και στη FEMA που είναι η Federal Emergency Management Agency. Τώρα ασχολείται με τα Big Data στο e-commerce.
We will talk about the analytics in KAYAK and how we use analytics to make KAYAK a better company and more profitable. And KAYAK had a big success in the United States. It was sold last year for almost $2 billion, and now it's expanding internationally. We have the website, the Greek website, 6 months ago. We launched it. And I'm proud to say that a big part of this success came from the analytics team and from the projects we do in analytics in KAYAK. So let's start the presentation. I want to start with an internet philosopher, Sting, who very prophetically said, every move you make, every bond you break, every step you take, I'll be watching you. Every single day, every word you say, every game you play, every night you stay, I'll be watching you. And this is what e-commerce website analytics are. This is what we do and why we do this. Not for any malicious purpose, of course, but we do it to better the user experience and to provide better products and make our users want to use KAYAK and of course optimize profit for the company. So this is a list which presents the highlights of what we do in analytics in KAYAK. We'll dive deeper into each one of these items, but I'm going to go through them now. First of all, the accuracy. So we use analytics to ensure that the results we present to the users are accurate in terms of pricing, in terms of number of stops, in terms of description of hotel rooms. And you would assume that the data we get from the aggregators are always accurate, but that's actually not the case. And we'll talk more in details about that. The next thing, a big project, is about speed. We try to optimize the speed of the KAYAK website, but without sacrificing accuracy. And this is particularly important. If you think about it, why Google became and won over all the competition when it started? Well, a big reason was that it was way faster than the competitor search engines. So the same thing with KAYAK. We started, and one thing that distinguished us from the competition was the speed. So we pay a lot of emphasis, a lot of attention to this, and again, we use analytics. Relevancy. This goes into personalization, and we want to present to our users results that are relevant to them, right? So if one searches for a hotel in some Greek island, let's say, and that person is used to stay in 3-star hotels, then we shouldn't be presenting 1-star hotels or 5-star hotels. But we'll talk more about it. We use analytics to launch new products. For example, the hacker fairs, which I'll explain later what it is. Of course, we use marketing analytics, in which we optimize how the marketing is spent and optimize the ROI, the revenue from marketing. And finally, another big area that we're involved in is in bot detection and blocking. So we receive a lot of attacks from bots, and we want to prevent this and stop them because they are not only affect us negatively in terms of performance, but also they can cost us money. Okay. So let's start with the first one, the accuracy. Fair accuracy. So as I said earlier, we get the data, the fares from big aggregators that they tell us that from a trip to Boston, Athens, for example, a flight, these are the available flights, these are the available prices. However, there are some problems. There is caching that is involved So they're not real-time data. And if users book certain flights and they don't have any more available seats, but we still show those flights, then this is an accuracy issue. Our users will click and will try to book that flight, but the airline will tell them, sorry, this flight is not available anymore. Even worse, sometimes we present a price. We'll say, okay, well, this is the flight for $230. The user clicks on that, and when they are redirected to the airline site, it tells them, no, this flight is $300, which is really bad. So we try to detect and prevent these problems. The accuracy has two components. One is the findability, and the other is priceability. And findability is for our users to be able to find the prices and the data that we present. And of course, the second is, as I mentioned earlier, the prices have to be accurate. So the causes of inaccuracy is, as I said, there are aggregators. We don't get the data directly from each and every airline. There are thousands of airlines. Instead, we get most of our data from big aggregators like ITA, which they do the job of converging, of getting all the data and aggregate them from all different airlines, or hotels for that matter. But there are, again, they're caching many of the data. There is a timing issue. Let's say that the aggregator got the data from JetBlue at 3 p.m. and sent them to us. And then we start presenting this data to the users. But JetBlue comes up with an offer at 4 p.m. Well, we have an old price. And other issues. So what do we do? How do we handle that part? We use predictive analytics, and we train models with data over the past, let's say, 2 weeks from a given provider, an aggregator. For example, for ITA, which is a big aggregator, and for the United Airlines, let's see what was the accuracy. Let's see what kind of flights they had. They were accurate and they gave us good data, and which ones they were inaccurate. And there are many attributes that we use for the prediction, many features, actually over 40 features, right? Which can be the origin destination, the number of stops, what is the locale, did they search in the United States, in Europe, how many days until departure, is this for a flight that departs tomorrow or next week or next month, and so on. And we built a predictive model based on all these features, and this model can tell us that with this price is accurate with 93% likelihood. So we would display that, right? But if for a different price, the model tells us that there is 60% or 50% accuracy, it's that likelihood that this would be accurate, then we hide that, we filter it out. And what are the results? The results is that without the models we used to have, before we deploy these predictive analytics models, our overall accuracy was 72%. After the models, we jumped to 88%, and nowadays is even higher than that. And the complaints. Now, every time we present an inaccurate price, some users will send us email. Actually, many users will contact us and say, hey, you told me that it was $200, and I go to the airline website and it was $250. So we get a lot of complaints when we display inaccurate data. But with the model, the complaints went down, and this is just a sample. For Delta Airlines, we got 2 complaints per week now versus 9 we had before. For United Airlines, we have 9 complaints now versus 23. And for Northwest, we have 5 complaints per week versus 189 complaints per week. So overall, this is a project that helps us make our users happier and, of course, better user experience. The next area is about speed optimization. And I will talk about flight speed optimizations, but we also have speed optimization in hotel searches and other areas as well. But for flights, what are some of the parameters, the complexity parameters? Well, it's first of all, let's think about it. If someone wants to fly from, let's say, Boston to Athens, right? There are many ways, many itineraries. Someone can fly through Zurich, can fly through Amsterdam. Maybe there is a direct flight, but also there are some other flights with more stops. Let's say from Zurich to Berlin and then to Athens. Maybe those flights are cheaper. Maybe people are willing to consider those flights. And furthermore, there are some itineraries that, for a human, they are, nobody would want to fly first to Abu Dhabi and then to Delhi and then to Athens. But for the computer, it looks possible. But we need to draw a line. We need to say that, well, there are certain airlines that we want to present to our users, certain flights, and certain flights that we don't want to present to our users. And this will help us improve the speed. And furthermore, we optimize speed based on what are the queries, or what are the results, rather, that are most likely to be clicked by the users. And of course, what are the ones that are most likely to be accurate. So we use a streaming approach in which we retrieve faster the results that are more relevant to our users and that are more likely to be clicked, and we present them quickly so that the user has some results right away within a couple of seconds. And then for the rest of the results that take longer, we present them when they become available. And again, this is a better user experience. Nowadays, people on the internet, users are not willing to wait a long time to get the results. You will lose them. Websites that take a long time to present results, they lose users. So we do our best to increase the speed. And analytics is the big driver in that front as well. Okay, the next project is a new feature or a new product we offered on our website is the fare forecasts. So if you do a flight search in KAYAK, you would see at the top left, you will see a little graph and a little advice that tells you that, you know what, the price that you found, the cheapest price that we found is likely to rise within the next week. So buy now. Or it might tell you that, that price is likely to fall. So it's better to wait. And we give also the likelihood, the confidence level for this prediction. This is a pure predictive analytics project. What we did is we trained models using terabytes rather of data and many millions of flights over a period of a year or more. And we saw how prices behave, and we try to create a model that will give the best advice, at least for the next 7 days. This is a feature that draws a lot of attention, and people like it because, frankly, it gives an opportunity for someone to save money if the model tells them that, wait, don't buy yet, wait a couple of days. Or if the model tells them that you need to buy now, the prices are likely to go up in the near future. So again, this is predictive analytics project in the most purest form. Another product rather that we created in the analytics team is the hacker fairs. So what do we mean by hacker fair? This is a term we baptized it with hacker fairs. So sometimes a round-trip flight is more expensive than if you buy 2 flights that are one way. Okay, so instead of buying the round-trip ticket, Berlin to Athens, you buy one-way Berlin to Athens, and then another ticket, a separate ticket, one-way Athens to Berlin. And sometimes these are cheaper flights. Now, how do we find the cases that these flights are cheaper? Right? We don't want to search all of them, because this would triple the amount of time and the amount of queries that we need to make to the aggregators. And of course, all these queries cost us money. They are not free. They're free for our users, but it costs dollars every time we make a query and we get data back from the aggregators. So it would cost us money to do the complete search. And of course, it would cost in time because it would slow down. It would make it 3 times slower. So we used analytics to figure out what are the cases that it would be most likely to have a cheaper hacker fare, a cheaper, in other words, combination fare, right? And we request data from our aggregator only for those cases. This product is pretty successful, and at least in the US. Many times you see the cheapest result that comes back is a hacker fare that no other websites offer, no other online travel agencies offer. Users love it, and many users choose to use that. Okay. The next one, another project. Let's talk about hotel ranking. So this is about when we show the hotel results to the users for a hotel search, we want to optimize the position that the user is most likely to click. This is a personalization project. This, of course, helps us by improving the click-through rate, right? And ultimately the conversion rates. So the more likely the users will click on a certain results, the higher the chances that eventually they will convert, they will do the booking, and will make money out of it. So this is something that benefits both the users because they don't have to go through pages and pages of irrelevant results, irrelevant hotels, but we try to present in the first page the most relevant hotels for the user, the hotels that the user would like most. So this is a big win for the user, and of course a big win for us in turn because we make more money at the end. How did we do this? Well, these are some of the attributes that we use for this personalization. We look at what kind of hotels the user has clicked in other sessions previously. We want to see, we observe the user, and this goes back to Sting's remarks in the beginning, that we watch our users, and we see for every user, we collect what kind of brands they like to use. What kind of filters they're interested in. Are they interested in, again, 3-star hotels, 4-star hotels, 5-star hotels? What are they looking for? We're looking at what kind of price level the user is at, and so on. There are all these features and even more, actually. Based on this, we train a machine learning model that predicts and personalizes per user what kind of hotels the user would probably like. And this is the loss function for this model, if we want to talk about math, but you really don't need to read this. The point is that there are really real math behind all these techniques. It's not heuristics, they're real math. And what we do is, to talk a little more in technical language, we train supervised learning models, and we use vectors of pairwise differences. We incorporate virtual examples to encode directionality constraints, and so on. And at the end, after every one of these, after we create each one of these models, we don't just throw it on the website and pray that it will work. What we do is we deploy the top candidates as A/B experiments versus control. And I will talk about the A/B experiments a little later. But the point is we test them, and then we choose the winning one, and then we fully deploy it. Okay, here's the results, some of the results. With using the hotel ranking algorithms, we improved the average rank of a click. So in other words, where the user would click. Is it the first result, second, third? So we proved it used to be before this algorithms, it used to be 30. In other words, the user had to go through 30, well, probably irrelevant results, right? Until he finds the one that they were interested in. Nowadays, it's the 5th result, on the average again, right? So it's on the 5th result, first page is the hotel that they're looking for. And this is great experience for the user. Our CTR has improved by 79%, and our conversion rates improved by 83%. This is great for KAYAK. 83%, we almost doubled the money that we make from hotels just based on this personalization algorithms. So great for the users, great for KAYAK, all driven by analytics. Let's move now into the area of marketing analytics. So in marketing analytics, the primary area that we're involved in is the search engine marketing, bidding optimization. So this is typically the results you see on every time you do a Google search. So if someone searches in Google for, hotels in Mykonos, right? You would see, of course, the Google results, but you would also see some ads on the right side. And there are companies who bid to put those results, these advertisements rather, next to the Google results. The question is, for every company that bids, how much should they bid? What is the optimum ROI, or how to optimize rather, how to increase the ROI? I spend that much money in advertising. How much money do I make? So we need to measure, we need to get the revenue that is associated with all these advertisements, and then use some fairly interesting math to optimize what kind of ads we want to bid for, how much should we bid? Should we bid, 10 cents, 50 cents, $1? How much? How often? In what kind of locales? In what kind of user searches? And so on. So there's a lot of analytics in that area. Another area in this in marketing analytics is what kind of attribution model do we use? If the user comes into our website through an ad and we make some money, where would that money be attributed to? So this is this is another sub-project into marketing analytics. And finally, it's the media mix modeling. How much money do we want to spend in SEM? How much money we want to put in display ads, in TV ads, and so on? This is, again, analytics-driven, this optimization. It used to be that the marketing officer will just look at the data and say, well, let's throw some more money on TVs and see how it does. Well, this is one way, but a better way would be to collect data, put some math behind it, and find the optimum mix. Okay. Now let's move to the A/B testing that I touched a little bit earlier. So what is A/B testing? A/B testing is if we want to deploy a new feature or a change in our website, as I said earlier, we don't just throw it out and hope for the best. What we do is we create an experiment and we segment our user traffic and we take a small percentage of our user traffic, let's say 5%, 10%, and we present the new version to those users. And then very carefully, we measure how much revenue we're making. And we compare this to the control. Control is the default website as it is today. And this is called an A/B testing. It's the A version and the B version. And then we see which one wins. And if the new feature wins in terms of revenue, great, we deploy it. So this is an example. And even for the smallest change, and maybe this is a good example. At the top, you see the default version of the website. At the bottom, you see a small variance of it. And you can see, for example, instead of having all room types, we have only 2 room types. And then we have a link that says see all room types, right? So it can be a small change, a small link, or it can be a small change in the colors. And of course, it can be a complete rewrite of the website, but we are careful not to overdo it. It's better to move very carefully with changes when the changes in your website affects millions of people. So we try to do it gradually. Okay, and this is now we'll talk about bots, bot detection. So the problem with bots is that many people use KAYAK, create bots to scrape KAYAK results and get them for their own use, maybe our competitors, or who knows what. And sometimes we've got a lot of bots from students. So there's a student in, some Chinese university that they want to find the cheapest flight from Shanghai to New York City. And what they do is they create a little, if they're computer science students, it's very easy for them to write a little scraper and just start scraping and start sending massive amounts of queries to KAYAK. Well, that's not good for us. It costs us money, right? And it clogs our website. It can make it slower and so on. So we want to catch, detect, and filter those bots. And what we do is we have algorithms that try to catch those bots, and we typically present a CAPTCHA screen, like the one you see at the top in the middle, in which there is a little question. The users have to solve it. And usually bots cannot handle these CAPTCHA messages, although you would be amazed. People have written bots that grab these CAPTCHA messages, they send them in other websites that are legitimate, other users solve them, and then they send us back the solution. And, they masquerade themselves as real users. So it's an ongoing problem. However, we had good success, let me see, with our bot detection filters. And in this graph, you see how, since we started using these machine learning algorithms and these filters, you see how the bot searches have dropped dramatically. And in particularly, the green line, which is the bot clicks, that is very relevant to us, how it went down to almost zero. So it's a great defensive measure. And look at the spike at the right side of the graph. That was an attack on Android API endpoint, right? And we didn't have detection rules for that because we didn't see a bot like that before. So it came in, it caused some problems in KAYAK, but we quickly gathered the data, used big data, analytics, and so on, and we created specialized rules. We trained a model that would catch that and filter out that bot, and after that, we successfully deployed the model, so the bot searches are minimal at this point. So in general, the philosophy in KAYAK is data always wins. We don't want to make decisions just by looking at some numbers and then scratching the head and say, okay, well, let's go this way. We want to make decisions based on real data, collect data, use science, use math, and see what is the best solution. And this concludes my talk. Thank you very much.